Our team is formed by Isabel Sandoval, Rafael Romo, and Maite Miranda, and we are students of the Architecture College in Mérida, Yucatán. Our main concern is about the air pollution. Mexico has the third place in pollution at continental level, and according to a study conducted by the Chemistry College of the Wadi, last year our city exceeded the levels of pollution in the air allowed by the regulations. The problem is that the amount of dust particles can no longer be filtered by the few trees that our city has, so we breathe them. And these particles are so small that can lodge in our lungs and even in our blood, which long term will seriously affect our health. It is for this reason that we decided to create an indoor air purifier, taking as our biological model the trees. There are models of air purifiers for homes and offices, but most of them are too expensive, use many resources for their manufacture, so generate even more pollution, use harmful chemicals that affect the health, and some of them are very noisy. Our proposal aims to create a product with all the pros of a portable air purifier, but without the cons. Based on biomimicry, we want to create a prototype that can be low cost, that is easy to build, that use recycled and reusable materials, and does not use harmful chemicals, that does not generate any kind of noise, and that suits the operating conditions of the environment, moisture, heat, dust, and be suitable for all the ages. We choose trees because they can survive in the most polluted cities and they have the first contact with the unhealthy air. We found out that everything has to do with the photosynthesis process. They are able through this process not only to create their own food, but also to clean the air around them. Each tree can eliminate up to 6% of dust particles and organic chemicals per hour, contained in the air within a radius of 50 meters. Their secret lies in the structure and composition of their leaves. They are formed by around 6 layers. The upper layer is a semi-hydrophobic protective veil, but with large pores that allows the air passage. In the second layer is the epidermis, formed by thinner pores where the larger bacteria remain. Followed by this, there is a layer with even thinner pores that divide the nutrients from other elements such as dust and bacteria, but lets the chemical pass to the fourth layer. Where is the xylem, containing the aloe vera, where all the harmful elements are decomposed by an organic chemical process. To the last layer, only the elements containing nutrients arrive, and from there they pass to the stem. The rest of the harmful elements are eliminated to transpire clean air. After this layer, there is a second protective veil. As the leaves or product also has 6 layers, the first and last one is a kind of honeycomb filter that simulates the large pores of the veil and allows the controlled flow of the air and dust. This is made of biodegradable plastic, and the mesh that forms the filter is made of ecological pet thread. After this layer, there is a reverse fan that sucks the air into the device. The second layer is known as the house of bags. Its walls are composed of ecological fabric that allows the airflow but remove the larger dust particles. And inside these walls create a vacuum that helps eliminate certain microorganisms. The third layer is a fabric filter similar to the previous one, but with smaller pores where organisms get trapped. As the previous one can be disassembled and washed to be reused, which ensures the durability of our filters. In the fourth filter, we wanted to recreate the functions of aloe vera. Our proposal was the creation of an alternative membrane with adhesive capabilities, but that still allows the flow of the air. The idea is to create a gel fluid containing the bacteria capable of breaking down the microorganisms present in the air, but allowing the airflow. This part is still in development because it's necessary a phase of experimentation and the knowledge of chemists and biologists. The last filter layer contains activated carbon, a porous carbon that traps compounds mainly organic, present in gases and liquids. We try to use a coal derivative from bones, since it's more organic and its pores are smaller, which makes it more efficient in the treatment of gases. Finally, the shape of our device starts from the physical principles of the airflow to achieve a more efficient product. It is formed by a truncated cone arranged diagonally in a pyramidal base. The cone has a section reduction, so the air outlet is faster, cleaner, and fresher. Given that the air tends to rise, we dispose the device at 45 degrees. And this product is buyable in cardboard or in a biodegradable plastic, and with dimensions that allows to be transported from one space to another. We expect that with the use of this purifier can contribute to the work done by the plants to clean our air, and that over time could improve both its form and its function, because this is only a prototype.